Alright, welcome back. So today I'm just gonna do a little simple dodging, the dodge mechanic and how to actually dodge or let the enemy know how to dodge. So the first thing we're gonna do actually is get a physical trigger. So you just right click inside the object or anywhere, create, and then go into logic and then physical trigger. And once you do that, you have the option to choose whatever type. I chose a sphere, 20 size, and it's like a circle that goes all the way 20. And yeah, that's our physical trigger. Then the next thing I did was, for our enemy and eyes, I was a bit lazy, so I gave them a second intersection mask, and I could say enemy, and we can use that for future purposes. And we're gonna keep that for now. The next thing we did was we added a node, a public node, and we called it physical trigger, and that's going to be where we connect our physical trigger. Now the next thing we did is actually we changed a few things here. So if I was to go over here, one we did was we added a visualizer and a render sphere that's going to render the circle in world. And then the next thing I did was I muted this for now just to show it. And the next thing we're gonna do is actually we're gonna do a case AI state dot dodge. So that's something new I made, and in this we're gonna write a logic where, or in the future you would write a logic where during this dodge time you have like a timer, maybe like 5 seconds of complete dodge, and then after that it's gonna go back into like aggressive or shoot, or you could skip this and just go into like a boolean or something. But we added a new state called a dodge. We made it just so we can check it out. The next thing we did was we added a physical trigger called a dodge area. Inside the dodge area we're gonna take that physical trigger node and connect it with these two lines. And we also made, where are you? A callback to enter dodge area. And this is where we're going to do our logic. So, last thing I did was I changed the world position, or where the bullet comes out from. Instead of the gun, we're making it coming out for the camera, just so we can have that accurate shot and you can see the dodge mechanic play out. Because right now we're just here to make the mechanics. You can make the nitty-gritty tiny details for yourself, but without further ado, let's write some logic. So this happens when an object enters, or an object with a body, rigid / dummy or anything, enters the area. Okay, cool. So the first thing we're going to do is we're going to make sure that the body that entered is not node itself. So we're going to do a body dot object dot name does not equal to node dot name. So that first filters out because there is an object inside it with physics and it's the object itself. So we can filter that out. Next thing we could do is we can just add no, I'm too used to C++. We can add a log message just to see which object actually came in. So we can do this way, and we could just say body.object.name and then /n, and that would just show us the object that entered. Right? And then what we could do is now we can draw another line just so we can see, or we can check what happens. So first we just check the object that enters inside this box. Now if the thing is a bullet and it hits us, then we dodge it. But if it just shoots in the area and it doesn't hit us, we don't really care about it. So what we can do is actually we can add world intersection, where we can check the pathway of the bullet, and if it hits us, then we do the dodging. So what we can do is Unigine.object, and I would say main object, just because I'm bored like that, world get intersection, and now we're gonna get the intersection between two objects. We're gonna do body.position, and then body.position plus body dot object dot linear velocity, right? Because now we're going to check how fast it's going. And then we're going to choose the intersection that we got the object in, which was 4. We changed it just so we could be, you know, a little bit check if you don't know what it is. You can click up here, and that is our thing. It's just a 4 at the moment, so we don't have to do anything fancy with the bit mask. But anyways, so it's a 4. Alright, and then we can also render this. And just copy paste this. Oops. Vector for yellow. Sure. And duration, I'm gonna give it 1 second because this is only gonna, it says is an enter callback, so it's only gonna shoot it once, so we can have 1 second of visualizer. Alright, so if so now we can do a little bit of simplicity. Is if we have the main object, okay, if it exists, alright, and main object dot name, right? If the name is the same as the node's name, right? And this is where you add the state equals to the state, what's it called? Dodge mode, right? If it's in dodge mode, then we do the whole logic of dodging. So it's a little bit what's it called, impractical, but it works in our position. So what we can do is we can add a vector 3 main vector, and this is going to be our main the vector that we're going to get, and it's going to be this guy, and we normalize this. Okay, so this object normalized, we're going to get this, and then we're going to get an angle that we want to dodge the object by. Now, you want a perpendicular angle, i.e. 90 degrees from this object. You could do the math, or you could be lazy and just go float angle equals to 90. Alright. Now this will save you a lot of time, especially if you don't want to calculate, but if you want like a specific dodge, like a fully perpendicular dodge, there you go. The next thing we can do is literally get a vector 3 rotating vector, and this is going to be the vector that rotates 90 degrees along this main vector. And if you guys remember your what do we call your physics, or actually no, your math, to rotate a vector you need x cos theta minus y sine theta, and then your y-axis you need x sine theta plus y cos theta. So let me just write it down. Alright, so that's going to be our rotating vector, and it just rotates 90 degrees along the x and y axis properly without rotating on the z-axis. So if you have an object that's flying in the middle of the air, you can use the z-axis too, but at the moment we are not doing that. So if you're gonna use the z-axis, you might as well just do a cross product, which is basically the main vector divided by the normalized, or it would be this linear velocity divided by this normalized. So I'm gonna be lazy and I'm just gonna do this, and then we can just visualize this. Alright, so now we're gonna have two vectors and it shows up for like a second, and then the last but not least, the main thing that we actually came here for, and it's gonna be node.world position equals to the same thing, world position plus rotate vector. Alright, and then we can just multiply it by like 5 or something, just so it can dodge like 5 units away, because our vector is already normalized because of this. So yeah, We can do that. And let's test this baby out. Alright, so we have this object. I just made him face us. Now if we were to walk in, it'll show us a line that shows our speed / where we are. If we shoot, the line will show us where our trajectory is. So right now I'm just shooting from the object, and now we have a bullet that entered. Now if we were to aim, it will dodge exactly 90 degrees to our left. So if we just go in, it also tells us that. Go in, it doesn't do that. And then bam, you shoot it, and it's always dodging to the right, or it's right. So how do we fix that? We can add some logic here on our angle, and we could do something simple. So if you guys remember the get the angle between two vectors, we can do that, and then we can choose. So let's do that. So mathlib angle, and then we're going to choose our vector, which is basically the world's position plus the direction, and then the main vector itself. So over here you notice that it's actually a vector 3 that needs to be worked here, so we gotta switch this to a vector 3, and that gives us our angle. Now this is just gonna give us our angle. What we're gonna do is we're just gonna do a ternary operator, which is basically angle, and we could do something like greater than 0, then we can say 90 or minus 90, and basically ternary operator requires that question mark, which I didn't put, and there we go. Basically the question is, if the angle is greater than 0, then we just make angle equal to 90. If it's not, we make it equal to negative 90, so it moves left and right. And we can see it play out. So if I shoot it over from the left side, he's gonna move to the right, or his left, and if we move it, he's going to dodge it the other way. Alright, so now that we have our dodging perfection, oh, there you go. As you can see, he dodged our object really well, and bam. Alright, so now we have a dodging logic implemented. So here's our mechanic, and you could play with this however you like. You can make it into an AI state like how I did, or you can make it like a boolean where in a certain amount he is in dodge mode, and then after a few seconds he'll be back to like his normal regular schedule. Or you could make it even crazier where he's actually in aggressive mode and dodge mode, and he's still aiming at you and shooting you or something. But yeah, the freedom to choose what you want is up to you. I think this is it for mechanics. I don't know how much more mechanics you want. Invulnerability, just make it so that his health bar doesn't get hurt. That's pretty basic. But yeah, that's about it. I think the next one will definitely be path making, and we will talk about it later on next episode. So until then, I'll see you guys. Goodbye.